Hello. I want answer from one or two participants that why you joined this course.
Should I answer? So I joined this
Yes.
course basically for your topic. We want to design and rainwater harvesting for our institute.
You want to design rainwater harvesting for an institute. That's a great
Yes.
answer. Yes, anybody else? Why you joined this course? Only one participant?
Say something.
I want at least 2 to 3 answers.
Try to gain experience in practical what you are facing, the problems.
Okay, try to gain experience. Okay, anybody else?
So we are here
Third.
to see the recent trends in water designing. What are the most recent trends that are being adopted in real life situations?
Water designing. That's great. Okay, anybody else? Anybody else? No one. See, I wanted to know that any one of you is interested in making money or earning money by joining this course. Any one of you is there? You can raise and I can see you. I think I can see all the participants up to first, second, and third bench. If someone is sitting on fourth bench, I can't see. Can anybody raise hand that anybody joined this course to earn money? Or you find this question odd?
Question is relevant,
Hello?
sir.
No. I am asking you that whether you are interested in earning money by attending this course.
Yes, sir.
Yes. Only one answer, yes, sir. Actually, you all have to answer yes, sir. We want to earn money, and this course, the course which you have joined, it is designed, and what you are studying or understanding, it's in a big demand in the market. I'll just show you at the end of this presentation. That is in my second presentation. Let us first understand about roof water harvesting, right? And an option for water sensitive urban design. What are my contents? This is the article which you can cite, you can use it, and you can cite appropriately whenever you are using it. And as I said that this is the topic, this is not only the topic for understanding it, but as rightly pointed out by ma'am, I don't know the name of her. Yes, you will be able to design rain water harvesting system for your city, for your campus, for your house, right? This is the roof water, so you can do it for your house also. You can do it for your community hall also. You can do it for campus also. You can do it for your society also. So this is the most relevant topic and most significant topic of the present time. Water demand, availability and extremes, water resources by 2050, artificial recharge, roof water harvesting, recharge structures, and at the end, I'll be going to show you the Government of India schemes. So one side you will say that the world is facing floods, other side they are facing drought. Global water demand for all uses presently about 4,600 kilometer cube per year, will increase by 20 to 30% by 2050, up to 5,500 to 6,000 kilometer cube per year. Global water demand for agriculture will increase by 60% by 2050. India has 18% of the world's population. But if you talk about water resources, only 4% of its water resources make it among the most water stressed in the world. This is according to World Bank's report. The global water cycle is intensifying due to climate change, with wetter regions generally become more wet and drier regions become dry. If we talk of water crisis, the UN says that only 81% of world's population will have access to safe drinking water at home, leaving 1.6 billion without it by 2030. This is the United Nations prediction about the state of current water. According to Niti Aayog, we have seen about the word. Now what Niti Aayog says of India. A report of Niti Aayog warned that India may face the worst water crisis in its history and 21 Indian cities will run out of groundwater in near future. 40% of Indians will have no access to drinking water by 2030. That is the statement of Niti Aayog. The first extreme case, I don't know whether you are aware of this or probably you have seen in the news, that's extreme events of Cape Town. The world's first water crisis that has happened in Cape Town in 2018. And this is the map which you can see the graph. X-axis there is a timeline, y-axis there is a volume of water, stored volume of water. You start from 13-14, 100% storage capacity, to if you go to 16-17 and 17-18, almost it is the day zero for Cape Town. However, they were able to avoid the day zero in Cape Town by taking certain measures like reallocating water, diverting agriculture water to city supply. Residents and business become water wise. At the most extreme point of the crisis, residents were limited to use only 50 liters of water per capita per day. Can anybody tell me what is the limit of water usage for us, for urban dwellers?
130.
As per CPNCO menu?
135.
130 liters per day per capita per day, right? So what they did in Cape Town, they have restricted them to use only 50 liters, and this has again gone down to 25 liters per residence per day. Increasing the cost of water, unfortunately, very few cities of India have metering, and because of metering, they have to pay, like you are paying gas bill or you are paying electricity bill, they have to pay for light bill also. But they don't need to pay for the water. Water bill comes in our tax. If you are living in the municipal range, then that house tax, it's a part of house tax, and 1,000 rupees in Surat I am paying 1,000 rupees for entire year as a water charges, which is very less than the cost of water which Surat Municipal Corporation treat and supply. If you take the cost of water which is treated by Surat Municipal Corporation and supplied, it is not only one time, two time, but maybe 10 times higher than the amount which I am paying to Surat Municipal Corporation. Day zero has been avoided in Cape Town because of this measure. The city's largest supplier of water, the Thief Water Scoop Dam, has seen an impressive increase in dam levels from 11% on March 9, 2018 to 100% on October 2, 2020. This is because of good rainfall, successive good rainfall in the year 2019 and 2020. Can anybody tell me in near past which city of India experienced day zero? You know what is day zero? Definition of day zero? Hello, can anybody tell me the definition of day zero? What the meaning of day zero? The municipal authority says that there is no water to supply. That is called day zero. And this has happened in near past one of the Indian city. Can anybody tell me which city it was?
Chennai.
Yes, it is in Chennai. So you will see next slide. On 19 June 2019, Chennai city official declared that day zero, or the day when almost no water is left, had been reached, as all the 4 main reservoirs supplying water to the city has run dry. And you can see the picture of 2018 and 2019, that is Google image. This has happened because of 2 years of deficient monsoon rainfall, particularly in late 2017 and throughout 2018 had led to this crisis. You might have read in the newspaper that the people has to rush. As you can see on the upper picture, that people have queued to collect 1 quart of water. Even the water was sold at very high rate. You can see that auto in the picture. Behind the auto, there is a line of vessels kept to fill the water. And this type of scene, they were very common in 2019 in the city of Chennai. In the 2010s, groundwater use globally amount to 8,000 cubic kilometer cube per year. India, the United States, China, Iran, and Pakistan accounted for 67% of the global extraction. More than 30% of the world largest groundwater system are now in distress. If we talk about India and if you talk about the global, so globally also 30% of the world largest groundwater system are now in distress. When I am showing this picture, probably you may feel afraid. The day will come when we also have to strive for a glass of water, because most of you are staying in Indian cities, and it is, and not to happen this, let me appreciate the present central government, the steps they are taking to make India from water stressed to water rich is adorable. Very few of us know this. At least as a water resources engineer or as an engineer, you should know that what the ministry is doing, the present government is doing to make India from water stressed country to water rich country. That I will show you at the end of this particular presentation.
So there is
The
national water
simple
mission.
message. Hello. The simple message
National
is that water. Hello.
I
Any
just said that national water mission is there, Ministry of Jal Shakti.
Yeah, ma'am. Yeah, national water. Apart from national water mission, also there are many schemes, right? National water mission is one scheme. Har Ghar Har Jal, that has been given by Narendra Modi recently. The simple message is that water resources will decrease dramatically by 2050. One side, the issue of quantity. Other side, the issue is of quality also. Right, as someone has rightly asked me a question, sir, how the Gopi Talab has been filled, or what is the source of water for the Gopi Talab? Here you can see that at present 12% of the world's population drinks water from unimproved and unsafe sources. More than 30% of the global biodiversity has been lost because of the degradation of freshwater ecosystems due to the pollution of water resources and aquatic ecosystem. We all are learned, probably all are civil engineer. Can anybody tell me what is the difference of treating surface water and groundwater? Can anybody tell me, if surface water is polluted and if groundwater is polluted, what is the difference between these two for the treatment?
So surface water has more the suspended impurities, and the groundwater has the more the dissolved impurities.
Okay, I am asking treating of the surface water and wastewater, rather surface wastewater, and if the groundwater is get polluted. Hello, anyone?
Sir, I
It
think
is
treating
very
groundwater. Am I audible, sir?
Yes, you are audible.
Yes, sir. I think according to me, treating groundwater will be difficult because once groundwater is infected, it will be affecting the soil present here as well. So no matter whatever we are doing for treatment, soil will be contaminated. So compared to surface water, there will be more contaminants even after treatment if we compare both type of water.
May I know your name, ma'am?
Sir, Sakshi
May I know
Gupta.
your name?
Sakshi
Sakshi Gupta. And what you are doing?
Sir, I'm research scholar here. Right now on study leave from my job. I'm into teaching.
May I request all the participants to clap for Sakshi? May I request all the participants to clap for Sakshi? Some of you have not clapped. I don't know why you are so confused. You should clap it properly. She has given an exact and correct answer. If surface water is polluted, it can be treated. If groundwater is polluted, it is very, very difficult to treat it, right? And that's where I really salute to Sakshi that you do have the correct information, correct knowledge about the water resources, right? And because of that, you need to preserve groundwater carefully. So talking to the water quality, so what are future challenges by 2050? Number one, availability of water will be reduced. Number two, water resources will reduce. And number three, that is pollution will further reduce the amount of clean or fresh water. Right. So this is the map of India. The water level, you can see the red, where the water is available more than 9 meters. And when it comes to the 9, that approximately comes out to be in terms of feet, it will be around
30.
right. So you can see that the almost so many parts of the India, they have the water level post monsoon 2018. This is the picture where you can see how the water level is depleted all over the country. So what is the solution then? Then the solution is artificial recharge to groundwater, that is recharging. The solution to this problem is recharging. And when the solution to this problem is recharging, first of all, try to understand what is artificial recharge. Because when we listen the artificial recharge, we tend to feel like something artificial. No, nothing is artificial here. Artificial is used as a word here. Artificial recharge to groundwater is defined as the recharge that occurs when the natural pattern of recharge is deliberately modified to increase the recharge. It is nothing related with artificial recharge. It is the pattern of recharge which we are modifying, which will increase the recharge to the ground. This definition is given by American Society of Civil Engineering. The process of recharge itself is not artificial. The same physical laws govern recharge where it occurs under natural or artificial conditions. What is artificial is the availability of water supply at a particular location and at a particular time. That can be made for water can be made available. If it is not available at that location, by transferring water from one place to another place, right? That is only the thing which is involved artificially in case of artificial recharge. The right side picture, can anybody tell? Of course, I have written below it the source, so probably you maybe immediately make it out. Someone is from Maharashtra. Anyone is from Maharashtra? Participant, raise hand. I can see you in camera. If anyone is from Maharashtra, yes. Which place? Which area?
I'm from Ratnagiri.
Ratnagiri. Okay. So I think Ratnagiri and around the Ratnagiri is also water stress area in case of Maharashtra. Is it not?
Yes, sir.
Hello?
Yes, sir.
Yeah. So this is the picture from the Maharashtra wherein the Pani Foundation has done lot of work. They have just changed the face of Vidarbha, which is considered to be a water stress area, into at least water sufficient area. I will not say that it is full of water, but at least it is a watered area, no more water stressed area. And that work has been carried out by Pani Foundation. In the broad sense, one can define artificial recharge as any procedure which introduce water in a previous pervious stratum. So what are the various methods for artificial recharge? So artificial recharge can be direct surface techniques or direct subsurface techniques. When it comes to direct surface techniques, flooding, basins or percolation tanks, stream augmentation, ditch and furrow system, over irrigation, these are all the surface techniques by which the water is recharged into the ground. While the subsurface techniques is injection well or recharge wells, recharge pits and shafts, dug well recharge, borehole flooding, natural openings, These are all through which the water is recharged in a subsurface way. Combination of surface and subsurface, basin percolation tanks with pit shaft or valves. The percolation tank which I have shown you along with the recharge shaft, that is combination of surface and subsurface technique. And indirect techniques include induced recharge from surface water source and aquifer modification. How to go for recharge? If you want to go for artificial recharge, how one can go for it? So first of all, you have to identify whether the recharge is required in this area or not. How you can find it out? Areas where groundwater levels are declining or on regular basis. The water level goes down over the year. Those areas where the recharging is less and withdrawal is more. Areas where substantial amount of aquifer has already been desaturated. Areas where availability of groundwater is inadequate in lean months. Before Narmada main canal, the Saurashtra and Kutch region of state of Gujarat, where the bores were done up to 200 feet depth or even more than that, right? So this shows during the summer period, that is non-monsoon period. So this is an example that the groundwater is inadequate in lean months, that is in summer months. Areas where salinity increase is taking place. Surat is facing this problem. The areas which are close to the coastal region, they have salinity increase. So what are the scientific inputs required before carrying out the recharge, going for the artificial recharge? So the scientific inputs are hydrometeorological studies, hydrological studies, soil infiltration studies, hydrogeological studies, geophysical studies, chemical quality of source water, and suspended matters. These are the 7 inputs which are necessary before undertaking any artificial recharge work. One by one, we will see what these 7 points mean. So first is hydrometeorological studies. These are undertaken to decode the rainfall pattern, evaporation losses, and climatological features. These can bring out the extent of evaporation losses in post-monsoon period, which will be helpful in designing the storage of particular capacity with a view to have minimum evaporation losses. You want to have, suppose you are planning to go for a recharge structure like pond, which I have explained you in the earlier lecture, that if high evaporation is there and if you can go for a deeper pond, it is good because the surface area is less, evaporation will be less, and you can have more storage of water for a longer period. Hydrometeorological studies. The data on rainfall intensity, number of rainy days, this is very much important. Number of rainy days help in deciding the capacity and design of the artificial recharge structures. Hydrological studies, that number 1, what is the source of water, in situ precipitation on the watershed, surface suppliers from large reservoirs located within basin, surface supplies through trans-basin water transfer, and treated municipal and industrial wastewaters. So what is the hydrological studies pertaining to water, availability of source water? These are the possibilities from where you can get the source water, and that can be used for the purpose of recharging. Hydrological studies also include the quantity that may be diverted, time, rainy days, number of rainy days are known. So from that you can able to compute that how many days are available for recharging. The quality, what is the type of water, if it is direct precipitation and if you are without any contamination of surface water surface, if you are diverting into the recharge, definitely the quality of water is good. If it is not, then you have to check the quality also, and a conveyance system required to bring the water to the recharge site, right? Soil infiltration. Infiltration is nothing but the process water entering into a soil through the soil surface. So I have given the example of IIT Jodhpur, where you will find the depth of the rock 30 to 60 centimeter below the campus. If such conditions are there, infiltration will be very less, and there you have to go for recharging carefully. So that also you need to check that what is the infiltration capacity of the soil. There is a maximum rate at which water can enter soil at a particular time under a given set of condition. The rate is called the infiltration capacity. Infiltration capacity depends on many factors such as soil type, moisture content, organic matter, vegetative cover, season, air entrapment, formation of surface seals or crust, etc. Some of you who are attending this lecture probably teaching this how to find the infiltration. Can anybody tell me how you demonstrate that practical to your students?
So can I
How to
get
find
a
out? Yes, yes.
very small experiment? We just take a can and then
Name. I am asking name of that experiment.
name infiltration. They just measure the time and with the stopwatch and what is the rate at which the soil will infiltrate.
Yes. That is single ring infiltrometer and double ring infiltrometer. So you have to have two rings and you have to pour water into it, and with the passage of time you have to record the water level depletion. This is called as an infiltrometers. And nowadays it is a IoT based sensors are also available which will be able to find it out, right? Actually that is used for soil moisture. I'm not sure about infiltration whether they are using these sensors, right? Then soil infiltration studies, that you have to carry out. Porosity determines storage capacity and also affect the recharge rate, the resistance to flow. Thus infiltration tends to increase with porosity. In order to know infiltration rates of soils, infiltration tests are carried out. Cylinder or flood infiltrometers are common type of instruments which measure the infiltration. Maps showing infiltration rates of soils are prepared which help to design suitable artificial recharge structures. There are maps also available which you can then hydrogeological studies. As I said that in the regional geological map indicate the location of different geological strata, their geological age sequence, boundary, context of individual formation, and the structural expressions like strike, deep, faults, folds, fractures, intrusive bodies, etc. These are required to be carried out. I'll give you one example. I'll not name the industry. The industry people came to one of the consultant asking for hydrogeological investigation of the site where they wanted to construct industry. The consultant visited the site and he said that the hydrogeological study can be carried out and the cost of carrying out that site, that work is 5 lakh rupees. The industry people felt this 5 lakh rupees too much and they didn't go for hydrogeological investigations. They constructed all the buildings and you will not believe they started facing problem immediately after constructing the buildings. They've gone for the basements and the basement started leaking. The water started leaking inside the basements. The water table was high and there were streams passing from their campus, and therefore the location as well as the design of foundation that is required to be done in such a way that they should not face this problem. I'm not sure that you are aware of this fact or not, but nowadays hydrogeological studies for before purchasing land by MNCs, big companies like Amazon, Flipkart, or any other big companies, that has become a common practice. And they are paying consultancy charges in terms of lakhs of rupees to these type of agencies which are carrying out hydrogeological investigations of the sites. Why? Another example. The government say to one particular industry, they will give the land free of cost. Before accepting the land, the company, that is multinational company, assigned job to hydrogeologists to investigate it. And they found that the site was originally a dumping site. And over the period, that has been covered by the soil. So if they go for the industry there, the cost of foundation, because it is a dumping site, the cost of foundation will be more than if they buy the new land in adjoining areas. And then after the hydrogeology, that report of this investigation submitted to the industry asked the government that we will not like to have this particular land. You can give us land somewhere else. So that is the significance of what you can say hydrogeological studies, right? So this is again the same thing which has been explaining the satellite imageries of the map providing informations on regional hydrogeological rock units, right? Even you have to go for on-site testing, right? That is resistivity meter and that is geophysical investigations. In that we are using the magnetometer and that is resistivity meters to find it out what is the thickness of various strata, right? It works on the resistivity principle and it gives you, as it is in the last line, that subsurface hydrogeological conditions economically, adequately and unambiguously, right? So you need to investigate where you are planning to do recharge. The subsurfaces are such that which can be used economically, adequately and unambiguously. Unambiguously means what? It should not contain any kind of pollution, or with the recharge you are putting water there and the adjoining areas may get affected by the pollution and people will start saying you that वो आपने क्या कर दिया, आपके वजह से हमको तकलीफ हो गई. So because of that, the geophysical investigations are also very essential before carrying out the what you can say the particular site. Then the source water. When you are recharging water, please be sure it should be fresh water only, right? Otherwise, as I said, that the surface water and that of the groundwater, it is easy to treat surface water, but it is very difficult to remove pollutant from the groundwater. Therefore, whatever water you recharge into well, it should have fresh water, or it should have standards equivalent to that of the drinking water, and then only you have to recharge it into it should be free from chemical and bacteriological analysis. Apart from that, suspended matter, your water should be free from surface suspended matter. If it is having suspended matters, what it will do? It will clog the filter media. The water has to pass through filters and then afterwards it will go into the recharge well or recharge tank. Then what will happen? The clogging will reduce your rate of recharge, and therefore your water should require to be free from suspended matters. The periodic removing of the mud cake and dicing or scraping of the surface layers. This is the what you can say how you can remove or what is the which way you can treat your suspended matter. That is explained over here. Up till now, whatever I have explained you, I have two questions and you have to reply it. The first question is, what is the expected percentage increase of global water demand by 2050? Anybody?
60%.
No.
80%.
No.
30%.
Yes. Somebody told correct answer. What is that? 20 to 30%, right? This is from my presentation only. The second question, how is this suspended matter which clogs the recharge medium be eliminated?
Double filtration.
Yes, that is what you can say. You have to go for filtration, and using the filters you can avoid it, right? Now, rainwater harvesting. Rainwater harvesting is a simple process used to conserve rainwater by collecting, storing, conveying and purifying for later use. The rainwater harvesting is one of the simplest and oldest methods of self-supply of water for households and residential household scale projects usually financed by the users. This is the picture of rainwater harvesting, where the rain is collected from the roof, then it can be diverted into rainwater storage tanks, right? The water can be collected from ground, it can go to the ground. From tank, it can be pumped and it can be again pumped into the main tank. The rainwater storage through filters, sand filters, it can be taken back again into the main tank. I'll explain it again in detail. Yes. Now, this is a very common, what you can say, sketch. And somebody will say that, sir, आप IIT में बैठे participants को ये दिखा रहे हो, right? One may have feeling like that, but without this, I cannot explain rainwater harvesting system, right? As I say that at the end of this lecture, you will be confident to design rainwater harvesting system. That is my guarantee. How? So there are very few components to design for rainwater harvesting system. Number one, collection area. Number two, gutter. Gutter matlab, this is the pipe, which is a horizontal one, which will collect the water which is flowing from, draining from the roof. That is collected into the pipes. That pipe can be taken into, there are two ways of storing water. One is a storage tank above the ground, and another one, that is the underground tank, right? Where the water can be stored into the underground tank, and later on, if it gets over flooded, you can divert it into the duck well. So this is the definition sketch for design components of rainwater harvesting system. What are the advantages of rainwater harvesting? Quickly, I will say it's the less cost, reducing the water bill, decreases demand for water. Yeah. Now helps in reducing the water bill. Anybody is here, sitting here, which is working in industry, and that industry is buying water? कोई है ऐसा बंदा जो यहाँ बैठा है, इंडस्ट्री में काम करता हो, and that industry is buying water? Hello? No one. Fine. Recently, last Monday only, I visited Sumul Dairy. Like Amul, Sumul is the milk producer company or industry that is located in Surat. We visited there to see the rainwater harvesting system. They are harvesting the rain, and we visited it. There, only single well, there are 10 or 11 wells, only single well pump 3 lakh liter of water per day, apart from the water which is supplied from Surat Municipal Corporation. That is because it's dairy industry need lot of water, right? They have carrots in which the water is in which the milk is supplied, and apart from that, there are other processes in which they need to use lot of water. Their monthly water bill, the Surat Municipal Corporation, which supplies water to Sumul Dairy, their monthly bill is 22 lakhs rupees. Water bill, I am saying, monthly water bill of Sumul Dairy is 22 lakh rupees. Here it is written, helps in reducing the water bill. After installing the recharge system inside their campus, they are saving 6 lakhs rupees per month. The bill has gone down from 22 lakhs rupees to 6 lakhs. That is 16 lakhs rupees, right? So this is the advantage of what you can say harvested water. Decrease the demand for water, reduce the need for imported water, promotes both water and energy conservation, improves the quality and quantity of groundwater, does not require filtration system for landscape irrigation. This technology is relatively simple, easy to install and operate. What are the disadvantages? It requires regular maintenance because the filter are required to be cleaned regularly. Requires some technical skills for installations. Limited and no rainfall can limit the supply of rainwater, right? That because it depends upon rain, and hence if it is a limited or no rainfall, probably this system will not work. If not installed correctly, it may attract mosquitoes, waterborne diseases. This is also very important when you are going for open trenches or pond. you should take care that it should not become a breeding center for mosquitoes or waterborne diseases. One of the significant drawback of the rainwater harvesting system is storage limits. Because in one monsoon season, how much water you can store? I will show you the calculations also, and it won't be possible always that you can store all the water which is falling on your roof, right? So methods of rainwater harvesting. So that can be rooftop rainwater harvesting, campus RWH, stormwater harvesting. Anybody who is sitting here and interested in research, taking up research in this area, this is the gray area for India, right? I do not know Ashok Sir is there in the audience or not, but in Australia, they are doing good work, right? Sir, are you there?
Yes, I'm here.
So this stormwater harvesting, which is done in case of Australia, right? That is, and when we compare it with the India, probably it is not even 0.001%. That's what you can say, the way in which Australia, I think the Australia is only world's country which has preserved, monitored, and functionally well water resources system. Am I correct, sir?
Yeah, you are right. And they're also trying to use stormwater even for potable supply. It has not been
that's
permitted
great.
yet.
Yes.
The health organization is asking utilities to demonstrate few years that they can manage the system well. And after that, they will allow to use that water for drinking purposes. But at this moment, they're using for non-potable applications. They have to demonstrate it. Yeah. So there's a lot of work is going on in this area.
Oh, that's a great news. And sir, in India, we are not at all utilizing, if I'll be saying that we are not at all utilizing storm water, or we are not harvesting the storm water. And one of the reason for that, though the recording is on, but everyone knows it, so I'm just for your information telling you, as your authority has said that you first check it and then afterwards we will allow you to supply for potable water. One of the reason why in stormwater harvesting is not done in our country is that these stormwater lines carry sewage, right? That is wastewater during non-lean period, right? Some of the stormwater lines. And because of that, as you know, that stormwater line should be free from any kind of contamination. Then only you can go for the recharging. So lot of work, the participants, lot of work can be done in case of stormwater harvesting in case of India. The deepened borewell recharge, deepened quarry and mines water usage, restoration and rejuvenation of water bodies. Ashok sir, this has started on a large way in India, this regeneration of water bodies, but not up to the extent of Australia. But still it is better than that of what we can say some 2 years back or 3 years back. That awareness has been created in India, and now they are regenerating the river water bodies, right? And there are number of projects assigned to various agencies, that is government and NGOs, right, to regenerate rivers which are flowing in their regions. Grey water recycling, reduce and reuse, right? This is again a gray area. The grey water recycling is again a gray area in case of India, right? So rooftop rainwater harvesting, the IS code, the ma'am, you wanted to design it. You just remember this 15797/2008. This is the IS code you refer. I think you are not required to refer anything other than that to consultant or expert for your doubts of designing. Otherwise, this is such a good code, IS 15797/2008, that if you have this code, you can design rainwater harvesting system effectively. So the factors which are to be considered for rainwater harvesting, first of all, the rainfall quantity. As I said, that rainfall, if there is a rainfall, then you can have what you can say runoff, and if runoff is there, then you can go for the harvesting system. So in IS 15797/2008, tables are given, table 1 and 2 of clause 5.1, which gives you that how you can compute the amount of water. Of course, there are formula also from this table, which is for flat roofs. If the rainfall of a region is 800 mm and the area of roof is 100 square meter, you can harvest 64 meter cube of water per season. I am talking of India. Ashok sir, not for Australia. Australia may be some other calculations for computing amount of runoff or which is required for or can be used for the rainwater harvesting. Sir, how you are computing, sir?
We have some softwares where, depending upon the variability of flow over the year, because during the month, each and every month, there will be different amount of rainfall. So depending upon how much water is being used in houses and also what is the rainfall pattern and the roof area connected. These are some of the factors which we can provide input to a software which is now available, which can be downloaded, and I'm happy to share with you the link. And you can put all that information into a software that you can optimize the size of the rainwater tank based on that.
Yes, sir. Yes, sir. So, participant, this IS code can be used for what the way in which the sir has explained computation of runoff, right? I'm going to show you in the next slide, but this is about this what very simple. Any participant who is sitting over here and wants to know that how much amount of water you can harvest, rainwater harvesting you can done, right? Simply open up this IS code, you see table 5.1, flat roof, find out what is the total of annual average rainfall of your area, right? And your roof area. And from that you can get the value of water available for recharging as per Indian condition. So 64 meter cube means participant how much liters?
64,000.
4,000 liters water is possible to be harvested from the rooftop. If the roof is not flat, but it is a sloping roof, so in that case, again, the table 2 is given in the IS code, which you can use and you can compute, right? For example, 1000 mm of rainfall, roof area is 200 meters square, then 190 meter cube of water you can harvest from your roof, right? Then, as rightly pointed out by Ashok sir, that rainfall pattern, how is the rainfall? Depending upon that, right, the area where rainfall occurs only in 1 to 2 months implies the storage requirement must be large so that the rainwater collected in monsoon can be used throughout the year. So, if the period is longer, you can have a tank of appropriate size. If period of rainfall is shorter, you can go for larger tanks, right? In India, many of the region, including Kerala, Madhya Pradesh I am not aware, Kerala, Gujarat I am aware, Rajasthan also I am aware, that in ancient time there were tankas. Tanka means tanks, which are constructed inside the houses, and that the roof water that can be directly transferred into those airtight tanks, and that can be used for rest of the months of the non-monsoon months. So this practice is followed in India. There are good number of literature available for these also, that what are the ancient practices by which we were conserving rainwater. Then intensity of rainfall. The maximum intensity of the rainfall will decide the peak flow, depending upon which the gutter size and diameter of drainage pipe be calculated. Collection of surface area. The collection surface area is restricted by the size of the roof of dwelling unit. Sometimes balconies and other projections are used as supplement to the rooftop collection area, right? Then comes the roof itself. In this system, only rooftop is the catchment, and the roof should be smooth, made up of non-toxic material sufficiently large to fill the tank. Again, participant, you will immediately understand what I mean by non-toxic material. But for Professor Ashok, probably he may get surprised that how this toxic material or chemical can come on the top of the roof. In India, sir, where there is a leakaging problem, we apply Damar or bitumen on it, right? sometimes to safeguard themselves from high heat, we apply paint on it. Apart from that, entire India is facing problem of pigeons, that is bird droppings. So bird droppings are not are also very common in case of Indian roofs, and therefore it is said that the roof should be smooth and made up of non-toxic material, right? And then only that water can be used for the purpose of recharging, right? Guttering and first flush device. This is very important. Guttering, which carries, this is the gutter which carries the water, and then after it comes first flush device. What does it mean? In India, we don't have water for 8 months. 2/3 of the part of the country don't have water for 2/3 of the period. Other part, 1/3 of the part.
Will it be disconnected after 5 or what?
No. Geo data come on, right? Maybe.
You're talking about the design of the, so I will give you one report and that will help you.
Sir, I was my connection was lost for a minute. I was not able to hear you what you said.
No problem, sir. No problem, continue.
Okay. So guttering and first flush device. So first flush device, right? This is the gutter and this is the pipe. First flush device means what? Because of all this reason which I said earlier, the after first rain, water should not go into the recharger and it should be flushed out. That is, therefore, the first flush device is to be provided as a part of your rainwater harvesting system. I will show you in the next slides. Then the filters. The filters are of two kinds. One, online filters, and that of purpose-built filters. The online filters is used when availability of runoff as well as recharge rate of recharge valve is less. Manufactured from reinforced engineering plastic material, available in various sizes and flow rates ranging from 3 to 25 meter cube per hour, easy to open and clean. I'll show you this online filter also. This purpose built filter, they are the simple filters. The filter material recommended is coarse sand of 1.5 to 2 mm size at the top, followed by gravel 5 to 10 mm size and boulders 5 to 20 centimeter at the bottom. The thickness of each layer should be 0.5 meter, half a meter. So this picture shows that how the leaves and all that should not go into the water. That is first flushing out of the first rainwater. The middle one shows the built filter, wherein the sand, aggregate and pebbles, each of 30 to 50 centimeter can be used, and the rainwater can be passed over it, which can be used for the recharging purpose. And right hand side is filters which are available in the market. In this you will see that Downtech pipe, the pipe which is coming from top goes inside the filter, right? And there is a valve here, you can see, and the pipe which is going inside the ground, that is underground tank, there is on that pipe there is a valve. So this valve you have to keep closed when there is a first rainfall, and the water will directly flush out of the roof. The roof water will flush out. It will not go into the tank. And when you open this valve, which is on the tank pipe, right, then only the water will go into the underground tank. So this thing you have to do after first rain, so that all the impurities, dust, etc., that should wash out, that should come out of it, and it will not go inside it, and inside the, what you can say, the underground tank, right? I have a filter. I don't know whether it will be visible or not. Is it visible?
Yes.
One minute. No, this video.
No, sir.
Not,
Video is not visible. 1 minute.
We have to manually operate this bulb.
I'll see that how I can share. 1 minute. I'll share share. Content, where is video? Yes, this is the video. How to share. Okay,
Yes, sir.
first, okay, and this one. Is it visible?
Yes.
Okay, okay, fine. You can see how the leaves are going into the central pipe. And here you can see the leaves have come out of it. While the clear water that's only goes to the storage tank. So I hope you understood, all you understood how the filter works.
Yes.
Hello.
Yes.
Okay, okay, fine. I'll close this video.
I just asked, after the first flush, do we need to manually close that, open that other one?
Yes, yes, while that you to close it, open it after the first flood. Okay, so now again my presentation is visible.
Yes.
Okay, fine. So this was all about the working of filter. This is another filter. This is also the filter which is online. You will see here the blue one, right? That is kept open for flush out the first ray, and then afterwards it will go through this filter into the ground. And this filter is also made of the filtering material. This is available for 10,000 rupees to 15,000 rupees in the market, but it's very easy to clean. You have to just open it from the top. Your Mali or your watchman can do that. Open it, clean it, and you can keep your filter media back into the filter. And the life of this filter is approximately 10 years. So such type of filters are available in the market, which can be used for the purpose of cleaning water, or only allowing water to go into the tank. The storage volume you can calculate as per IS 15797, as the sir has explained. V is equal to T into N into Q, where T is length of the dry season, N is number of people going to use the tank, and Q is consumption in liters per capita per day, right? And from this formula also you can work it out the storage volume. This is not the roof water volume. Please remember that thing. This is for your storage purpose. You wanted to design a storage tank, right? You don't want to recharge water into well. If you want to recharge water into the well, no need of this calculation. But calculation is required that how much water is you are recharging into the ground. But this one, for that you have to do separate metering, and if you will do the metering, you can check how much quantity of water you are recharging into the recharge well. But if you want to design a tank, again you refer 15797 2008, V is equal to T into N into Q, and you can design the tank. I have taken one example of it. The tanks may be of two type: storage tank above the ground and underground tank, right? This is the storage tank underground, 5 meter by 3 meter, which I am using for the purpose of designing. All right, before that I have again a question: which IS code is used for the design of rooftop rainwater harvesting? 5797 208, right? Okay, fine. Okay, the second question: what care is required at the time of first rain of the season?
First flush.
Flush it out. Okay, that's great, participants, right? Estimation of rainwater harvesting for house of rooftop area 1000 square feet. 1000 square feet. So this I have calculated. Water availability 100 square meter, rainfall 850 mm. So from IS code I have worked out 68 meter cube of water that is available yearly. Okay, the diameter, gutter size 100 mm, and width 176 mm, again from the data given, which you can find it out from table number 3 IS 15797 2008, right? So gutter size has come, available water 68 meter cube. Volume of tank, how will you decide? The available water is 68,000. Available water is 68,000 liters, while your requirement is 120 days, 4 number of people, 135 LPCD. So you need 64,800 liters of water. Accounting for losses, make it 0.87. It is 57,376 liters. So tank which you have to design is of 56,376 liters, against which the water available is 68,000 liters. That means the sufficient amount of water is available for normal annual rainfall, and you can go for a tank of 56,376 liter. What type of a tank you wanted to design? For example, I wanted to design for RCC tank. What are the other components? Manhole, which is to be provided 0.6 meter, overflow pipe 100 mm diameter, drain pipe that is of 100 mm diameter. So this is the plan, which you will have 5 meter by 4 meter size of the tank, which will have the sectional elevation, in which you can see on the top you have to provide manhole, the top cover 30 centimeter thick ferro cement cover or 15 centimeter thick RCC slab, you can put it on the top of it. And let us see what is the cost of it. So according to GWSSB, that is Gujarat Water Supply Sewerage Board Schedule of Rates 21-22, according to this, the estimated cost I have worked out for this tank having this specification. These specifications are very standard, and probably any one of you can use when you wanted to give it to your client, because all the relevant IS code you can see here: IS code 3370, IS 3370 part 1, part 2, IS 456 for concrete, IS 1893, IS 875. All the codes have been included for what we can say the construction of the, as a specification for construction of this. These general specifications are also carried out. The shape of container, size shall be fixed, effect of overlapping of pressure bubbles, right? Then the care shall be taken that no damage should occur to nearby existing structures. Minimum concrete grade. See, what is the minimum grade specified? M30, right? HYSD FE415 500 grade. प्राइवेट क्लाइंट होगा तो वो नहीं करेगा, उसको आप मत दीजिएगा. No, don't give it to private client. You can go for one grade lower. But if, because this is a government SOR, as because of that they instituted for M30 grade of concrete and FE415 500 grade. For private client, you look, you see what is the condition of your area, and accordingly you can give. So if you give M30 grade, then also no problem. It will have a longer life, right? Then minimum size of various components, safe bearing capacity, SPC, pipes, what kind of pipes you have to use, the rate of dewatering. In case suppose you are excavating the pit and that time come water starts draining into it, that excavation dewatering is also on the part of the contractor, and therefore I am saying that these specifications are very good, very well drafted specifications, right? So the cost, it is given in terms of liters. So for 50,000 liter, the tank cost is directly given 2,82,500. Less than up to 50,000 liters, it is 5 rupees 65 paisa per liter. And for additional capacity from 50,000 to 1 lakh liter, the additional cost per liter is 2 rupees and 26 paisa. 1 lakh liter, it is 3,95,500. So using this specification, I have worked out the cost of my tank of 68,000 liter as 5,37,880 rupees. If you take it in terms of liter per year, so it comes out to be 7 rupees 90 paisa per year. And if you consider the life of tank is 15 years, hardly it costs 15 paisa per liter per year. So it is that good, that easy, right? That you can use, or you can design such type of a tank and use it, right? So I think we are running short of time. I'll just show you, and then afterwards I will show you the government policies. These are the actual roof water harvesting system. Professor Ashok, This is installed in my campus. My campus have 22 wells and recharge wells, and all the hostel building, administrative buildings. You can see 3 pictures here. First, in the first left hand side first picture, the downtake pipe is there, which is coming from the rooftop of hostel building. In second, it is carried at the ground level, and third picture, you can see the water is discharged into the recharge well. So this is a recharge well in which in the center there is a recharge pipe. It is a perforated one, so that the water infiltrates, which the pure water which infiltrates from this filter media, because there are perforations right on this pipe, cuts on this pipe. Through that vertical cut, the water will drain into the recharge well. And you can see the quality of water in the picture also. If you will see it properly, it is a crystal clear water. You can directly drink. That's the good quality of water. You can recharge it. These are again the picture of SVNIT campus recharge well. All recharge wells are there. In third pic, you can see the water is there, but I do not know whether you will be able to just pick it up, that there is some depth of water and then the pebbles are submerged into it. This is another campus in which the rooftop water is taking out. The flushing arrangement is also, you can see here, and that can take water directly into the ground. This is a ground tank which is provided over here. General design feature: the substances that go into the making of the roof should be chemically inert. Roof surfaces should be smooth, hard and dense. Roof painting is not advisable. No overhanging trees should be left near the roof. No bird dropping nesting should be there. Gutter end should be fitted with a wire mesh screen to keep out the leaves. Appropriate arrangement for discharging the first flow of rainfall should be made. The storage tank should have a tight fitting of roof. No light should enter into the tank. The flushing pipe at the base of the tank, there should be no possibility of contaminated wastewater flowing into the tanks. That also you have to ensure. Management and maintenance: during the rainy season, the whole system should be checked before and after each rain, and preferably cleaned after every dry period exceeding a month. At the end of the dry season and just before the first shower of rain is anticipated, the storage tank should be scrubbed and flushed of all sediment and debris. Ensure timely service before the first rains are due of all tank fixtures, including replacement of all worn out screens and servicing of outlet tap or hand pump. So this is what we have talked about. Directly from rooftop water, we take water into the underground tank. What are the other ways by which we can recharge the recharge, or how we can use the rooftop rainwater? So for that, rooftop rainwater can be discharged into aquifers. The first condition is water table greater than 8 meters below ground level. Then only you can recharge. If the water level is above it, you cannot do the recharging, right? It's already a role of saturated medium, right? So where the water table is greater than 8 meters below ground, then you can go for the recharging of aquifers. What are the data required for design of recharge structure? So for recharge structure, layout plan, demarcation of the roof area, delineation of stormwater drains, details of existing groundwater abstraction structures, computation of the runoff for recharge. What are the recharge structures? So recharge pits, recharge trenches, recharge dry or operational dug wells, recharge through abandoned bore wells, and recharge wells. So quickly, the recharge pits up to 100 square meters, recharge trenches between 200 to 300 square meters you can use. What should be the depth of recharge pit? 2 to 3 meters, and the filter media, boulders, gravels and coarse sand be used for the recharging of it. Then comes the recharge through dry or operational dug well. So again, water from the rooftop through filter media, it can be taken into the dug well, right? Then this is another picture of how water can be taken into the dug well from the filter media. Then recharge into abandoned bore well. Before recharging into the bore well, abandoned bore well, first you have to check whether it is active or not. And for that, you have to take tanker of water, at least 10,000 liters, and allow it to and pour into this pipe. If all water get absorbed, then this abundant tube well is active. Means it is possible to recharge water into the ground or aquifer. If it is not going, then what we can say that it is not suitable for what we can say putting the water into it. I have seen this practice. Many of the houses in case of state of Gujarat, they are recharging water directly into the borewell. Sometime back when I was delivering this lecture, one participant from Delhi, she called me, she asked me a question online. Sir, the street in which I am staying in Delhi, they are highly congested, and you are talking about the harvesting of rainwater. Then I suggested this measure to her, that you can take your roof water, provide the flushing after first rainfall, and you can divert that water directly into your existing borewell. Right? So sometimes it happens that if I am staying in a very congested street, how can I do the rainwater harvesting? But it is possible. You can divert it into the existing borewell also, not abundant, I am saying, existing borewell also, and that will improve the quality of water. So recharge structures, this is the kind of recharge valves through which you can do the recharging of aquifer. Details of it. This is again a recharge well, recharge shaft that I have shown you. In case of SVNID campus, we have number of its percolation tank. We have already asked. The maintenance part, that also I have discussed. What is going on over the world as far as the recharging is concerned? So under heavy traffic area, such type of tanks are constructed which can store the waters. This is the park or a school compound in which you can have such type of arrangement by which water can be diverted to the aquifer. This is the water collection, storage into the tank, and then afterwards it is diverting into the ground. Again, rainwater storage for this, right? Quickly, I will show you, as I am saying that we are running out of time, but let me show you that what government of India is doing as far as the recharging is concerned, right? Hardly it will take 5 minutes. Yes, is it my screen is visible?
Yes, sir.
Okay, so efforts of government of India for recharging, right? So in case Ashok sir, in India, water being a state subject, steps for augmentation, conservation and efficient management of water resources are primarily undertaken by the respective state governments. So this is advantageous also. At the same time, to implement certain scheme, it has been felt that if it is under the control of central government, then probably it is possible to manage water resources in a better way. Again, it is a question of debate that whether the resources be managed by state government or a central government. However, the schemes, if we talk about the schemes which government of India is doing, the first one is Jal Shakti Abhiyan 1, that is JSA 1. So government of India launched Jal Shakti Abhiyan 1 in 256 water state districts of the country in 2 phases between July to November 2019. To promote water conservation and water resources management by focusing on accelerated implementation of 5 targeted interventions: water conservation and rainwater harvesting. Apart from renovation of traditional and other water bodies, tanks, reuse and recharge of borewells, watershed development and intensive afforestation. This is the first scheme. Then the Jal Shakti Abhiyan 2, that is Jal Shakti Abhiyan again, rain, catch the rain. Honorable Prime Minister of India launched the Jal Shakti Abhiyan Catch the Rain on 22nd March 2021, being the World Water Day, with the theme Catch the Rain, Where It Falls, When It Falls, to cover all the blocks of all districts across the country during 22nd March 2021 to 30th November 2021, the pre-monsoon and monsoon period. The focus intervention for JSA includes again water conservation, rainwater harvesting, and all that which were included in Jal Shakti Abhiyan 1. Then the Atal Bhujal Yojana. This is one of the, I said in the beginning that the government Ministry of Jal Shakti, after the incidents of Chennai, which has gone out of water, the government has become very active, specifically in this area. Or after the Niti Aayog report, the government of India is very active in conservation of water, and this is one of the scheme. I think that I'm very much hopeful about this scheme, in which Atal Bhujal Yojana, central sector scheme with focus on community participants, demand side interventions, and convergence of ongoing schemes for sustainable groundwater management. As itself, Atal Bhujal Yojana means Atal underground water scheme, and that is specifically meant for groundwater management. And this scheme is from 1st April 2020 in 7 states, that is Gujarat, Haryana, Karnataka, Madhya Pradesh, Maharashtra, Rajasthan, and that of the Uttar Pradesh. This may be extended in other states also, right? Then Atal Jal is focused on sustainable groundwater management, mainly through strengthening of the capacity of states to manage their groundwater on the one hand, while improving groundwater management with community participation through preparation of village level water security plans and convergence of various ongoing schemes on the other hand. The strict law, earlier anyone can extract any amount of water from the ground. Now there is a law that before going for a bore well, you are required to take permission, right? Atal Mission for Rejuvenation and Urban Transformation. The Atal Mission for Rejuvenation and Urban Transformation was launched by the Government of India June 25, 2015 in selected 500 cities and towns across the country for a period of 5 years, that is 2015-16 to 19-20, which has been already extended for completing the grounded projects. The mission focuses on the development of infrastructure in the mission cities, of basic urban infrastructure in the mission cities in the sector of water supply, sewerage and sewage management, stormwater drainage, green space and parks, and non-motorized urban transportation. I asked a question that any one of you have joined this course with the aim that they want to earn money. This is the scheme which is for those who wanted to go for consultation, those who wanted to go for construction, execution of the work which are planned and which will be executed under this scheme. And in terms of crores of rupees has been given by central government to the states to carry out these projects. Then comes the Jal Jeevan Mission, Har Ghar Jal, that we are talking about. The government India in partnership with the states is implementing Jal Jeevan Mission, that is Har Ghar Jal, which aims at providing potable water in adequate quantity of prescribed quality on regular and long-term basis to every rural household, including tribal areas of the country, through tap water connection by 2024. And lot of innovative measures are going on in some, because it is a difficult task. Tribal areas are on the hills, so in hills there are hand pumps, and then for operating of that hand pumps, from where they will get the electricity, and for that they have gone for solar panel, so that pumps, hand pumps operate using the solar energy, and that supplied piped water to housing in tribal area or hill area, which are approximately 100 meter, 200. They are not at one place. They are scattered all over the area, and there using the solar energy, the pumping is done and the water is supplied to the tribal areas of under Jal Jeevan Mission, Har Ghar Jal, right? Then FFFC report. This is also interesting that 50 million plus cities, 2/3 of allocation of funds under challenge fund of rupees 38,196 crore is meant for metering service level benchmarks on drinking water supply, rainwater harvesting, water recycling, solid waste management, and sanitation. Right? So ample scope is there in India for next at least 5 years in this area. Right, wherein you can be a consultant, you can be a contractor, you can be an advisor, right, wherein you can be a part of all these schemes which are going on all over the country to improve. As I said that by 2030, it is predicted by Niti Aayog that 20 cities may run out of water. But after seeing these efforts of Government of India, probably that will not happen. Thank you very much. I've taken more time than given to me. Thank you so much for your. So if you have any question, quick question.
The question. Thank you, sir. For nice topic, nice lecture.
Thank you very much, Professor Yadav. It was very interesting and informative. And I think even for me to see what is happening in India, because I also worked in water industry or water organization in Uttar Pradesh nearly 30 years ago, but things are moving quite fast. And it is very interesting to see that what programs are coming up now to meet the water requirement for the community.
Thank you, sir, and looking forward to have your research association in this area. I thank Pramod sir also for giving me opportunity to deliver this lecture at GAN course, and I thank all the participants who were interacted during my both the sessions and actively participated. Thank you very much.
Sir, can you share the PPT file?
Yes, sir, I will share it. I'll share it.
You can send the mail. Okay.
Sure, sir, I will share.
Thank you, sir.